Hi, welcome back. Today, I want to continue on the tricky SQL questions journey that we have kicked off last time. I do want to tackle some of the FANG or MANG questions today. And I would primarily want to focus on how to optimize your query and reduce the size of your query significantly. That's the main focus, but let's dive into one of the hard SQL questions that was previously asked by Meta. So let's dive into this question. If you're following my series of SQL tricky questions, this is from Meta, and the platform is Stratascratch. The title of this question is Rank Variance per Country. Um, the question is which countries have risen in the rankings based on the number of comments between December 2019 versus January 2020? Hint, avoid gaps between ranks when ranking countries. So we have two tables, essentially Facebook comments count and Facebook active users. And we are trying to get the rankings of both in between the months December 2019 and January 2020 based on the number of comments. So if the number of comments have increased, there should be a higher rank. Versus this December 2019 versus January 2020. So a couple of tricky nuances in here. The rank is however you want to define it, whether you want to say it is directly proportional to the number of comments, then you want to give them a higher rank. Higher rank, that's the key here. If you want to define the higher rank as one, an ideal scenario, the logic should identify a higher rank in January 2020 because we want higher comments directly associated with the rank. And in order to avoid the gaps, which is the primary hint that is given in this question, we want to narrow down our search to dense rank. Because in dense rank, if you are ranking based on a certain partition, a certain category, in this case, you're ranking based on the country, and within each country, we need a ranking for December 2019 and a ranking for the January 2020. We do not want to have a scenario where a normal rank will skip the following the consecutive two ranks if there are same ranks given to the category. So we do not want the situation where the rank is being skipped. Dense rank will solve that problem. It will give a continuous rank, meaning it will assign the same rank if two records have the same ranking. So it will assign number one, one if two records have the same ranking, and then followed by two, two, two if three records have the same rank, share the same rank too. So let's dive into this question. And I want to identify the brute force method, which is always a good place to start. So I am identifying the rank for December 2019 using the dense rank function here. And I'm identifying the rank for January 2020 individually. And essentially narrowing down my search to identify the variance or identify how the ranking is changing between these 2 months we just talked about. So it is a straightforward approach, and this solution definitely works. That's great. But today I want to find a more optimized way to do this, and I'm going to drop some comments here. More optimized way to tackle this question in two simple changes. One, I'm going to condense the CTEs into one. We don't really need two CTEs. We can condense both of them into one. So that's what I'm going to do for starters. And then in the second scenario or the second step, I am going to identify the cases where the rank is higher using self-join. Those are the two simple steps I'm going to follow here today to optimize our logic for this question. Okay, we already have the brute force method. Identify the ranking individually for each month and bring them together, compare the rankings, and identify the solution we're looking for. So now I'm completely going to comment out the second CTE. That's the step number one. We got that taken care of. And now I want to simply change this into a condensed CTE where I have both the months being ranked at the same time. We don't really need two CTEs, so I'm condensing the dense rank function and the CTE into one single CTE. So I'm calling this as ranking and calling out both months of interest. Okay, that's what I'm doing here. However, we need to partition by the month because we want to identify the ranks. And if there is no partition by the month of interest, it is going to rank across these months. So if the ranking for, if the number of comments for 2019 December is higher and the ranking for 2020 December is lower, it's going to rank it's going to give the same sequence versus we want to identify the sequence separately. So I'm going to partition by the month year. We have already defined the month year here and ordered by the number of comments. That's the key metric. Okay. Now we are going here to identify the country and just change this to ranking. It is a self-join scenario here, and I'm going to call it out as add a couple of quick tweaks here. I'm going to say the December month year in 2019 12. I want to make sure that's what we're bringing in because we want a comparison against 2019 December. And within this, I'm also going to make a quick change where my January month is well defined also. Okay, so we are going to bring in all, we're going to do a self join and make sure we call out the month of comparison first, where we are also trying to bring in the comparison months with December and the January 2020 and simply compare the ranks. Okay, let's try and run this. Looks like there is a slide. Okay. Oh, oh, it's ambiguous. So we need to call out. Okay. Doesn't really matter. We can call out one or the other because we are going to make sure. All right. So we are calling out the January sequence. So the reason I use January here is there can be an edge case where December there is no ranking. Basically, there are 0 comments. Case where number of comments could be 0 or null. And in January 2020, there is a rank due to number of comments is not null, right? So in December of 2019, there are no comments, so there's no rank assigned. But in January of 2020, there are comments and we have to assign a rank. In that scenario, since there is no rank, it's not going to be able to compare it. In those scenarios, we still want to make sure if there is a no rank assigned in December 2019, we still want to get those records. That's exactly what it is doing in this step. Okay, we used a simple OR operator to fetch those records, and it runs pretty fast. So it is actually 10 times more faster, 10x faster, and also 50% less code that we need to execute. This will be very, very beneficial if you're trying to run the same logic across millions of rows and hundreds of millions of rows. That's all for today. We'll catch up again. Thanks.